see if I can make this smaller here. Hello. It's been like a semester since I've seen you. Okay. Yeah, we're about to get started, so you are just in time. Shit, I need to preheat the Trident. It's just rendering and stuff today.
Oh, it's rendering it?
Yeah,
Okay.
rendering it finally. Okay. Hello. Hopefully everyone can see me. I know this printer is kind of in the way of some people. But hello. I'm Andrew. Now I guess you've seen my face, but now I can also see all of your faces. This is Frederick. I'm not sure if Avantika is with us today. I think she has an exam. But that is okay. Hello. Welcome to week 5. You've made it. I'm so glad you're here. Today again, we're doing a demo. Like I said, I'm pretty excited about that. So while this printer heats up, I'm just going to talk a little bit more about materials and a little bit more like technical stuff in regards to 3D printing and stuff like that. And then we're going to do rendering. So you know how to render your finals, and then we can get you out of here after the demo. So yeah, without further ado, I think we will get started. So I'm going to be doing some rambling about materials. Obviously, there's a super like wide range of materials that are available to us, especially when it comes to 3D printing. So I'm sure there's a material that I'm not going to talk about today that you probably know, and you can be like, oh, what about this material? And yeah, that probably is out there. But I'm just going to highlight a couple of them. There's new and better materials that come out all the time. So this PowerPoint isn't always the most up to date. But yeah, let's just get started. Yep. Okay, you can't really see this very well. But yeah, there's a huge variety of materials that you can use for 3D printing. And all of the materials have their different strengths and weaknesses, right? Some of them are really rigid, but then with the rigidity comes like making the material like more brittle. Some materials are more flexible, which can help with like impact resistance. And some stuff are like completely flexible to the point where you can like squish it, which is pretty cool. Hello, Harry. Um, but yeah, there's a wide range of materials with a bunch of strengths and weaknesses. With those different material properties comes different printing parameters. So you might have to print things faster or slower, um, hotter or cooler. And then obviously price comes into play too, depending on what material you get. So I'm just going to talk about a few here. And yeah. So the filament that a lot of you might be familiar with is something called PLA or polylactic acid. It's just a very basic material that is technically biodegradable. It technically is in like strong parentheses or quotations because it needs very specific conditions for it to be biodegradable. But it's a really great material because it's cheap and it's really easy to print. So a lot of people who print stuff print things out of PLA. If you ever receive like some 3D printed desk toy or something, most of it's PLA. And the reason is because it's pretty easy to print fast nowadays. It comes in a wide variety of colors. And you don't really need like some insane setup to get this to print good. So you technically don't need a heated bed. And you can print at temperatures like as low as 180, though I'd recommend, somewhere over 200 plus degrees Celsius. You'll see in some of the other materials, they slowly creep up to be higher and higher. But yeah, PLA is pretty great. As a material, it's actually really, really rigid, which is pretty nice. So if you want something to be nice and rigid, then PLA is a pretty good material. Um, I would say the main drawback for PLA is it's temperature resistance. So like I print with this printer right here, and a lot of the components on the gantry are 3D printed. But because it's fully enclosed, the chamber temperature will get up to 60 or above Celsius. And if I printed the gantry in PLA, it would start to warp and then I'll be all sad, right? So I don't want that for my printer. But if you know you're printing something that's going to be in a climate controlled environment, PLA is perfectly fine. Um, but yeah, that's PLA. It's pretty great. I don't really print with it anymore, but it's pretty common. Um, ABS is another filament that was really common when we first started printing, and then it became less common, and now it's becoming more common again because printers are getting better. So ABS used to be printed just because it was really cheap, and it still is relatively affordable today, but it's significantly harder to print compared to PLA. The main reason is its temperatures, right? So you can see here these nozzle temperatures are a little bit higher. The bed's a little bit higher. I personally print my ABS at like 185 and like with a bed at 105. So, you know, sometimes like these numbers are just kind of a range, but you might print hotter or colder than that. So you can tell from those numbers that it's quite a bit more. But it's a pretty great material and you'll find it in almost everything. So a lot of plastic pieces that you'll get from like a factory are usually 3D printed. I mean, not 3D printed, ABS. So stuff like Lego and stuff like that is all injection molded ABS. So it's a pretty great material. It's got a lot of great properties. It's very strong. The gantry on this printer is printed in ABS, so it's pretty good material. Because of these high print temperatures, it can withstand like warmer environments, which is good. Um, but some of the cons are it's harder to print, right? So the main drawback to ABS is it's prone to warping. So last week I talked about warping in 3D prints, and you'll kind of tend to see that more with a material like ABS if you don't have good bed adhesion. Prints will start to curl and then they'll get kind of sad. So we don't like that. So that's why if you print ABS or a similar material, I recommend printing in an enclosure like this printer. It's fully enclosed. It keeps the heat in, so the ambient temperature will prevent the material from warping, right? Um, Also, the fumes that it produces when printing isn't really good. So if you've ever like modified a Nerf blaster and you had to like Dremel out like the area where the switches are, those are made of ABS and they don't smell great because they're not really good for you. So don't really, I don't encourage you breathe it in. So yeah, keep that in mind. If you're working with ABS, you might want to have it in its own dedicated space with, a lot of air or good ventilation. Lots of people get stuff with like activated charcoal filters to filter out the particles. So that's another good option. So yeah, just keep that in mind. But yeah, ABS is great. It's one of my favorite materials. I've been printing with it a lot recently. Today, I'm going to be printing ASA, which is a very similar material to ABS. Um, I like to think of it as ABS, but UV resistant. So if you didn't know, ABS is not UV resistant. So if you buy some things and then leave it outside, often if it's made of ABS, you'll see it starts to yellow or it'll become weaker over time. So ASA is a very similar material, especially mechanically, but it has that UV resistance. So it's pretty great. It's not on this list, but I highly recommend that if you want to print higher temperature materials. It's just like a little bit more expensive by like a couple dollars a spool, but it's not too bad at all. But yeah, the next material is PETG. So it used to be my favorite material before I started printing in ABS. And the only reason why I like ABS more is just because I can print with an enclosure now. But I personally like tend to favor PETG over a PLA, mainly for its temperature resistance. So it's kind of in the middle between ABS and PLA in that regard. So if you were to leave something in like your car, like for, on a hot summer day, a PTG part is more likely to survive compared to an ABS or PLA part. For my car, I printed like PTG stuff and I like put it in the engine bay, and it worked for a good while. And it honestly didn't fail, but I replaced it with ABS. So PTG is like pretty good. I mean, I wouldn't recommend you bolt it to your engine, but like, in the engine bay is pretty decent. But I would recommend probably ABS over that. Um, Compared to PLA, it's a little bit softer, so it's a little bit more flexible and impact resistant. It's still a pretty rigid material. Like if you tried to squish it, it's not really gonna move that much. But it has, some slight minor differences. Um, if you see my friend Harry up in front, he has a 3D printed Nerf blaster that I made for him, and most of it is made of PTG, and it lasted pretty good time. His thing has a tendency to explode, but that is his hobby. But yeah, PTG is great. I love it. I highly recommend it if you don't have an enclosure. And it's kind of odorless, so you don't really smell it. Again, I wouldn't recommend breathing stuff in near a printer, but you won't tell. But yeah, the main problem of PTG is that it's susceptible to moisture. So if you didn't know, some materials will like absorb the moisture and water molecules around them. And when you 3D print with stuff like that, it can result in like visual artifacts in your prints. So if you think about it, like your printer nozzle is like several times or a couple times over like the boiling point of water. So if you put a wet filament through it, you're basically going to be boiling the water as it comes out. So it'll bubble and ooze, and then your surface finish will suffer. So if you do print with PTG, especially in a more humid environment, I recommend you get a dry box, which will basically absorb some of the moisture, or get a heated dry box, which will heat up the spool and kind of evaporate the moisture out. So I'm from California, if you didn't know. So I actually didn't know this was a problem until I came here because California is so dry that it didn't really matter. So if you live in a dry environment, sometimes you'll be okay, but I do recommend some kind of drying system if you have it. Yeah, sorry about that. Someone sending me stuff. But yeah, compared to ABS, it's a lot easier to print, which is another reason why I recommend it for people who don't have an enclosure. It doesn't really warp that bad unless your prints are like massive and your bed adhesion's terrible. So it's a pretty good material. I like it, and it's pretty cheap. So that's another reason why to print it. TPU is a really cool material. It's very different compared to all of the ones on this list, mostly because it's extremely flexible and you can get it in like very different levels of like flexibleness or like short hardness if you want to use the scientific term. But it's extremely flexible material to the point where if you have a TPU print that's like low infill, you can like squish it. It's pretty cool. So it's very different, but it has its own application. If you have like multi-material or multi tool capabilities, you can combine different filaments together to make a special like one piece part with multiple materials. So that's pretty cool, and it's a good use case for TPU. I've heard of people printing like print in place hinges and they just use like a rigid material on the outside and then a flexible material like TPU interlaced with the part to make it one piece, but it's still flexible in certain areas. So it's really cool. I know a lot of people who print TPU and they've had great experiences with it. The only downside is that you have to print a considerable amount slower compared to other prints or other materials just because it's so flexible. If you're not set up to print TPU, like the filament can get jammed and like shoot out the side of your extruder if you're not careful. That's less of a problem now, but it's pretty cool. Um, yeah, some people are picking up finals. But yeah, it's a great material if you need something flexible. I highly recommend it. Again, you can get different hardnesses or different levels of flexibility if you really want to tune that in. So depending on your use case, this might be what you're looking for. With nylon, we're starting to approach the more like quote unquote engineering grade materials, mostly because they're harder and harder to print. Pure nylon is extremely hydrophobic, similar to PETG, but a lot worse, to the point that people recommend you print like out of an active dryer, right? So for PTG, you can like dry it, like leave it out for a little bit and print it, but nylon is so like susceptible to moisture that it can absorb enough while you're printing that it can affect the print. So if you're printing nylon, print with a dry box or something, keep it nice and dry. But if you can print it successfully, you get a really strong material. Mechanically, it's usually stronger than all of the materials I've talked about before. It's really rigid, it's really strong, and it's pretty great. Or yeah, sorry, it's a little bit uh more flexible. It's still pretty rigid, but it's pretty great. Yeah, I don't really have experience printing with nylon, but I've heard pretty great things. Again, you do need higher temperatures, so be careful. Also, it is kind of expensive, so these different materials will get more expensive as we go on. But yeah. Polycarbonate is also a pretty crazy material. If you didn't know, polycarbonate is what they use to make bulletproof glass. So it is a pretty strong material. So I think if it can stop a bullet, I'd say it's pretty good. Obviously, with the 3D printed part, it may not be exactly bulletproof, but it should be pretty good for what application you're using. Obviously, you see here the nozzle temperatures are going up, so it's a lot harder to print. Pure polycarbonate is really hard to print. And you need it to be really dry. Again, like nylon, printing out of a heated dry box. Obviously, at these temperatures, you really need an enclosure to prevent warping. But if you want something strong, polycarbonate's great. Um, Also, if you didn't know, some people talk about carbon fiber filaments. Polycarbonate is one of those materials that a lot of people add like additives like chopped carbon fibers into. So for a lot of the materials I talked about before, people add carbon fiber into it to make it more rigid. But if you didn't know, adding that carbon fiber actually makes the part heavier. So typically we think of carbon fiber as being something light, but when we talk about 3D printing, we're mostly thinking about rigidity. So if you want something extra rigid, then you can get like a material with carbon fiber in it, and it'll be even more rigid. So I'm going to be reprinting some parts of this printer in like a carbon fiber PET, which is pretty cool. Um, but it'll make the gantry more rigid, and then I can go faster. And I always want this printer to go faster, but you'll see in a moment. But yeah, polycarbonate's pretty cool, but it's pretty hard to print. So, um, unfortunately for us, like consumers, it's pretty hard to make or print something out of pure polycarbonate unless you have like an insane setup. So even like a printer like this might have a hard time printing polycarbonate, unfortunately. But yeah, anyways, that's just kind of an overview of these materials. I know I'm rambling a lot, so hopefully before you fall asleep, you can look at this graph and just kind of see that there's a bunch of different properties available to you for 3D printing. And depending on your application, you can pick and choose the right one for you. And also pick and choose the one that fits in your budget because the engineering materials get really expensive. But yeah. I don't know if all these links work, but there are many resources around the Purdue campus that offer printing. I also offer printing, so apart from the finals that you're gonna hopefully get printed once you finish this course, I do print on my own. But if you wanted to go to any of these resources, they're also available to you. There's also a high likelihood that you know someone with a 3D printer. And a lot of the times they're more than happy to make stuff for you. So feel free to hit up all your resources. I'm a resource. But yeah, if you want stuff printed, feel free to go there or to me. But yeah, with that, we're just gonna go into rendering and stuff like that. So we're gonna kind of move away from 3D printing for this final part, but then we're gonna revisit it with the demo. So we're gonna be rendering for our finals. Don't worry if you haven't finished your final yet today. Your final is due a week from today at midnight. So if you haven't finished it yet, don't worry. Yeah, you still got time. But today, the last part of it is just rendering. So if you ever seen like ads and stuff, you'll probably have seen a rendering of something. A lot of the times they don't have the actual product and filming it. I mean, sometimes they do, but a lot of the times they'll have a rendition of it and then they can like spin it and like it'll fly across the screen and stuff like that. Most of the time it's a rendering, and it makes your product look really nice and professional. So we're going to teach you how to do that today so you can hopefully make your final look professional, but also anything else you design in the future look really nice. So we're going to go into Fusion real quick. And yeah, I did not see the comments. Okay, cool. You got it. Thank you. Should I just close the chat? Okay, awesome. Thank you, Frederick. Or not make it bigger. Okay. All right. So for Fusion, can I like hide this? I'm just gonna move it over here. So for Fusion, feel free to open up any file that we've made in class so far. Please do not open your final project for this assignment. I'll have people send me their final project twice, and you won't get points for the first submission that you get. So basically how this is gonna work is we're gonna render one in class right now, but later on in your own time or after this demo, feel free to render your final, because I want two renderings. So one render is the one we're doing right now, and then another one is your final. So again, please don't submit your final. Just pick something that we've done in this class, preferably something with an appearance on it, just because you can see how those appearances show up in your rendering. Anyways, here you can see I have the Lego car assignment that we did. I'm missing the steering wheel, but it's okay. Um, you can see here, I'm just in my normal modeling space where I can add stuff, add, parts, add, extrusions or features and stuff like that. But you can see here on the top left, it says design, which is what we're doing right now. But if you click on it, you can see there's a bunch of other options. So there's like generative design, which is pretty cool. But there's also rendering. So today, obviously, we're doing rendering. So we're going to click on that and you'll see the workspace will change a little bit. Okay, cool. So you'll see here, I'm kind of in my rendering space now. You can see stuff is looking a little bit more shiny than it was before. You can even see there's a shadow because there's like a light source on our model. So this is pretty cool, but it's pretty basic. For one, like this part doesn't have all its appearances applied. So all those gray bits you're seeing earlier are now just gray. So if you wanted to add appearances, if you didn't do so before, there's this wheel up here that you can open up and it should be just like before if it opens. Um, and then you can add appearances just like you have, or just like you know how to do. So I'm just gonna apply a couple more. I'm not gonna do all of them, but let's do a couple more. So let's just make some of these parts green, or let's lag my computer. Great. 1 second. This crashes. I will be sad. Okay, well, while we wait for this, Does anyone have any questions about the 3D printing stuff that I just went over? I know it's a lot of information, so if you didn't get all of it, it's okay. But if you have any questions, feel free to ask because my computer is being slow. Nice. Okay, let's try this again. Let's restart this. Sweet. I love it when this happens. All right, let's try that again, shall we? Okay, I'm just gonna leave the model as is this time. But I'm gonna assume that the part you chose has appearances on it, just because it'll show up nicer in the rendition. But here we are in our workspace here. We've applied appearances, but now we want to set up the scene. So right now we have a really boring, blank background, but we can change that by editing the scene settings. So if you go up here, right next to the appearance button, there's a scene settings option, and you can open it up. This little pop-up will open on the side. You can control the brightness here, though I usually don't, because if you drag the slider any amount, it just makes your part look white. So I'm just gonna leave it as is. Right now, the background is set to solid color, which is why it looks so plain. But for these assignments, I'm gonna ask you to turn on the environment mode instead of the solid color mode. Just because, I want you to make sure you know how to use all these features. And if you just choose a very boring environment, then I won't know. So um, make sure you switch to environment. You'll see it'll change a little bit. And if we go into the environment library on this tab, you'll see you'll be presented with a couple of them. Um, are the good ones gone? Oh, did they delete them? That's so sad. Okay. I don't know if it's my Fusion being sad or something, but I can't find the ones that I usually are there. Um, is anyone open to this? Can you see anything other than these like lights, these cool lights? Okay, yeah, I'm not really sure why mine's not showing it right now. But please don't use any of the ones I have right now. I don't know why I can't see the other ones. But there's usually one that's like a plaza, that you can select. I recommend just choosing one like that for your final or something like that. It'll just basically plop your model into like a 360 cam like image, that's really high quality. So you can kind of place it in an environment where you might see your final, like being located. I know someone like made a guitar for their final, and then they had it like sitting against like a wall or like a windowsill for their final. Um, but yeah, please don't use any of these, like just the basic lighting ones, because if you use them, then I will think that you didn't apply an environment. There's some custom environments that you can download from the internet. Um, Maybe I should do that here. Um, But basically, once you've chosen your environment, I'm just gonna choose a random one for now because I don't know why um it's not showing up for me. But yeah, assuming you chose one that's not just light and it has like an actual background, you can kind of close out of this environment here, and we can start to render stuff. So there's two options when it comes to rendering. You can render like locally on your computer, or you can do a cloud render. So I'm going to show you how to do both, just to kind of, show you how everything
Yeah,
works.
it's class. We have a meeting. Oh, 15 minutes. Okay, okay. I'll leave. Thank you. You're welcome.
Uh, I will get to that in a second. But yeah, basically, if you want to make like a local render, just kind of uh periodically, if you just want to check to see how it looks before you do your final, you can do this in canvas render right here. So there's this play button. If you click on it, um, your computer will start to render it. Um, it's not going to be like super crisp like a final render, but it'll give you an idea of what you're working with, right? So you saw like right at the beginning, the screen was black and then it's slowly getting nicer and nicer. But basically, how the rendering works is it'll like divide different pixels into like subpixels to make it like more and more refined until you have a really, really nice design. Um, right now, my computer is being slow, so it doesn't look super great. But you can kind of see how this looks a lot more professional compared to just, sending a screenshot of like the way you did your homework to me, right? So this looks really professional. If you were to like, make a portfolio or something, you could render it and then, slap a nice image on it. The cool thing about the in-canvas render is that you can move it around so you can kind of place it where you like it before you do your final. So you see, like as I orbit, things get really blurry. But then when I let go, then it'll start to render, and then it'll start looking nicer and nicer. So you can use like the orbit and pan tools that you learned from week one to orient the part where you want it. Um, and then when you're happy with that, you can finalize your render. So when you're happy with it, you can just click the teapot here. It'll load and give you a couple options if it loads. Cool. So it'll give you this little window with a couple options. You can customize your size. I'm just going to leave it as it is right now. But the main difference is there's the local render and the cloud render. And because we're students here, we have the cloud rendering capabilities for free. So we can outsource all this rendering to, Autodesk servers instead of making our computer sound like we're at an airport and then maybe blowing it up if you have like a Chromebook or something. Um, so for your final, I recommend you use the cloud render option. Um, I would just set it as final just because it gives, a cleaner uh, rendering. And then you just press render. It's pretty simple, nothing too crazy. Once you press render, it'll kind of take a snapshot of the position that your part is in or assembly is in. It'll send it off to Autodesk and then they'll render it for you. So you'll see here down at the bottom, it's sending it out, and then it'll be rendered. Usually it takes around like 10 to 15 minutes, so not too bad, considering how long a really nice render would take your computer. I rendered something locally on my laptop once, and it took like 3 hours. So, I mean, I have a better laptop now, but I really recommend you use the cloud rendering service because it's pretty great. No harm to you. It just kind of makes it, and then you can call it a day. Um, but yeah, with that, you just kind of have to wait. I'm not gonna stand here for 15 minutes and not say anything. So we could probably do the demo while we wait for this. Um, but yeah, does anyone have any questions about rendering? Pretty self-explanatory, I assume. Cool. Awesome. Okay, so feel free if you want to gather around the printer as we do the demo. The printer's been preheating, so it should be ready to go anytime now. Does anyone have any like reasonable requests for what I should print today? Hopefully something like kind of small so you don't have to wait here for another hour for it to finish.
Something nerve related.
Something Nerf related. I mean,
Is it a short dart model?
I don't know.
I think we go through those, right?
Yeah. I mean, you're looking, that's like several hours of print time right there. But it's pretty fun.
So everything here is nerve, right? Like a 3D printing.
Yeah,
Also,
everything but like the hardware. So there's like springs and bearings in it. But like, the main body is all printed. If you were here earlier, there's an electric one that I brought in, but I gave it to its owner because I printed it for them. Yeah. Also, if you haven't looked at them yet, those are the finals from last session. So yeah. But yeah, feel free to pass these around. So this printer has multi-material capabilities. So I can print stuff like that dinosaur in multiple colors, which is pretty awesome. But yeah, what should I print?
No one can decide because it's just a benchy,
Okay, I guess I'm printing a speed benchy.
multicolor benchy.
No, that'll take like a couple hours. Okay, so for those of you who don't know, this is Orca Slicer. It's a derivative of Prusa Slicer. So Prusa Slicer, okay, this is kind of weird, but like open source code gets like copied and pasted into other things. So Prusa Slicer is like a derivative of Slick 3R, and then Orca Slicer is a derivative of Prusa Slicer. So it's just kind of like a chain of stuff. Prusa Slicer is great and all, especially for Prusa printers. But personally, I use Orca Slicer because it gives a little bit more fine control over certain parameters, mostly around like speed and acceleration and stuff. So that's why it looks different. I'm gonna add a benchy real quick and we'll get one going.
It's printing in red.
Yeah, I'll do red.
I don't know much about Kira other than I use Kira.
Cure is fine.
So that's how algae grows.
Okay.
Yeah.
So this isn't adhering to the speed benchy rules.
Yeah.
Let's go. Wait, I can print
I don't know.
I have red loaded up, so I can print a Charmander in red.
Okay.
Do you wanna send it to me?
Just this link.
Sure.
I mean, this is
Or you can like put it in the chat or something. I can try to, I'll probably be able to print, okay. I'll probably be able to print both of them before class ends. So, um, I'll try to print both. Okay.
I should have brought the art. Should have brought the slide.
So what's the material you guys use on like the list of materials?
So yeah, that's a combo. But originally it was printed in all PETG. The slide is now printed in ASA, which is again similar to ABS. They were all like fine, but I just started printing in ABS, so we just started doing more ABS stuff.
This is like very, it's like a tougher PLA, and then there's like
So
it's very hard to tell, but
so how do you assemble the arms? Just super glue or
no, it's just screwed together.
oh, just
Yeah. I don't have the specific tool to get the little more.
I guess we
Because to reach the screw here, you need a really long.
Okay, let's do this guy.
The mechanism it doesn't break the slide.
It does. It does. Yeah. I mean, I can show you guys, but it's really loud. So that's the thing. The string is pretty compressive. At full length, it's 12 inches. Right now, it's pretty compressed at like 9 inches, and when it's fully compressed, it's That's a lot of spring. That's a lot of spring in like this much area. So it's really loud. I should just shoot.
So how many times you can shoot this before it explode?
I don't know. I haven't really like kept track of it, but so far this slide has kept up about like 200 shots. Yeah.
How far did you shoot?
About more than 200 feet per second.
No way.
It'll break skin if you stand at point blank. So please don't do that.
Oh, this is better than the Nerf gun you got from Walmart.
Yes.
Yeah,
Those
it's-
are 70 FPS. This is 3 times as hard.
Yeah.
That was
Huh? Did you shoot in the leg?
The issue is that you know what you're getting into because the hardware for this, you see the core inside, that's a small little thing. That thing is it's aluminum and it's milled, so it's CNC, so that small little block itself is $20. That itself is $20. The hardware is like just like the bearings and the custom threaded rod and all that stuff. Shipped after attacking and everything, it's $9.
Okay, I'm gonna
So this-
unshare
easily-
my screen.
Yeah.
Hopefully you guys can
So-
see this.
Another one?
Uh-huh.
Yeah, it's.
Oh, that's a lame angle.
Yeah, so it's awful. The same, I did not design this one. This one, I customized it, so he did the majority of the modeling and all that stuff, make sure, got the mechanical part, I figured out. All I did was just.
Okay.
It's
I'm
just
gonna
a
place it
picture.
here if the cable's long enough, so please don't trip over it. It's like barely long. Just put my laptop. So I was preheating the bed. What?
You need to screen this.
I do.
Wait, hold on, we could just do this.
No, it's fine.
So you have.
No, it's
Doesn't work.
So I was preheating the bed, but it's heating the nozzle. Again, I'm printing ASA today, so my nozzle temperature should be like 285. Yeah, I think
That or that's just tracing.
that's wrong. I need to fix this.
Extrude it.
I blew up my heater last night, so so I need to lower these temperatures.
Okay.
How much is a replacement going to cost?
Depends on what part.
I mean, I bought like a pack of heaters for pretty cheap, like I think like $15. But it was cheap because the heat went up. So I'm gonna buy like a really nice one for like 15 and it should last. But yeah, you're probably looking at over like, I don't know, 13 or 1400 worth of printer right here. So I invested a good amount, probably too much. It's a hobby and probably an addiction.
How much they pay you to teach this course? You can.
No, no.
Not
enough.
I mean, yeah, I just do this because I like it, and I like teaching you guys. I mean, seeing these finals come out, really rewarding to me. And hopefully passing down some of my knowledge down to you, mostly why I'm here. I mean, it cost me like probably more than how much I make today to drive down here. So yeah, heat up faster.
So this thing can do like multicolor stuff, right?
Yes.
How does that
So
work?
the cool thing about this is I've been building this multi-material unit on top. So what it does is, again, it's a single nozzle. So every time it changes a color, it'll cut the filament and then pull it out and then put it in. So when you do multicolor prints, because of how the manufacturing process works, you have to do it on every single layer. So I don't know if he showed you a picture of like that Nerf blaster we made, but like that was like 800 like filament swaps for all 5 colors.
It's just one part as well.
Yeah.
Yeah,
So,
it's just for the slide.
like
That part.
it has to be a pretty robust system to do it reliably, which is what I've been working on.
You're building it yourself?
Yeah, I mean, some of it is designed by other people, but like, I'm adapting this from something else. So This printer is pretty nice. You know, I started back before there was like auto bed leveling, so this is like very luxurious compared to my first printer. What it's doing right now is it's trimming the bed. So you know how like 3 points make a plane? It'll probe 3 different points, and then all of these Z motors are independent. So if the bed was like sideways, it would make it level. Uh, Now it's um, probing the nozzle, and then it's gonna probe the probe to calculate the offset from the probe and the nozzle. So you'll see here, like it has like that thing that it's smashing into the bed, uh, and it's like a sensor that tells it how far away it is. So right now it's gonna calculate a mesh. So it's probing a bunch of points around where I'm gonna print. And then when it prints, it'll account for any deviation in the flatness. Uh, this like bed was like low, like flat. So it has a flatness of about like 0.2 millimeters across its 300 millimeter build plate, which is pretty good. But obviously, you know, it's not perfect. So we use probes to compensate for that. Um, yeah, now it's loading. And it should start printing. So the first layer is usually a bit slower compared to everything else, just to make sure it gets down reliably. But then once that first layer is done, it'll just kind of try to go as fast as it can. The nice thing about Orca Slicer is that I have like control over like the speed and acceleration of every single like type of feature. So like to maintain quality, I make sure to slow down on the outside layers or like outside features, just to make sure it's nice. But then like the inside that nobody sees, I can just go ham and go as fast as I can. So Orca Slicer is kind of nice for that. But yeah. If you're wondering like how fast this is compared to a bamboo, because bamboos are like usually what this thing gets compared against. Um, comparing to my friends like bamboo, this is about like 30% faster, which is pretty good. Um, but when I'm finished with this, it's gonna be even faster.
So does this like jostling not affect the print?
No, so in today's age, this is crazy. Uh, you know, my old printer would print at like, I don't know, maybe 40 millimeters a second. This thing is going like 300 for the ink fill. So like it's going really fast. And because of that, like there are a bunch of vibrations induced on the frame and the machine. So to compensate, there's a sensor that you can mount onto it, and then it'll vibrate at a bunch of different frequencies. It'll measure that, like graph it, and then compensate for it. So
Damn.
I don't have the sensor with me today, because I only need to run it like, you know, every time I make like a major hardware change, or that's typically when I do it. But I mount it to the nozzle. It'll run its test, and I take it off, and it's great. So yeah. Like if you look at those prints, like those blueprints were printed on like one of my older printers that doesn't have that capability. And like speed wise, like this printer is about 5 times faster than the old one. And you can tell like from the print and surface finish, like even at those speeds, the quality is still pretty good. In some cases, like I think this printer looks better at those speeds. So yeah. Um, but yeah, this when I'm finished, it should be able to print, you know, this should be able to print nylon today, but eventually I want to print even higher temp materials. So that's what this is kind of geared towards. Um, you can see that like the sides are insulated to keep the heat in. The top will be insulated eventually too. But at the moment, like its max acceleration is about 20,000 millimeters per second squared. So it's like accelerating at over at 2 meters per second every time it changes, or meters per second squared every time it changes its direction. So it's pulling like 2 Gs, which is pretty crazy. Once I finish, I'm gonna be printing at over 40 meters per second squared. So my goal is like 4 Gs or more when I'm finished. But that's gonna require some like hardware upgrades. So yeah. Is it worth it cost wise? Probably not, but it's really fun building it. So yeah.
Are the modifications to go faster things you make custom made for your printer, or are they just things you buy that already exist?
It's kind of a mix. So, like I said earlier, this printer is mostly 3D printed. Obviously, like the frame and stuff is metal, but if you look at like the gantry components and even the tool head, it's all printed. So the cool thing is, you know, some smart people will design like an upgrade that's even better, and you can print it out and put it on,
Oh, that's cool.
or you can design some yourself. So like, I've done like little things like in the corner, you can see like there's that little thing that's holding the wire to the tool head up. You know, I just modeled that real quick. Obviously, like this stuff is like 3D modeled and printed. But I kind of like that philosophy just because, you know, you can continually improve your machine and make it better. Or you can just make more. So like I have a bunch of other printers at home and like they printed the parts to make this. So it's kind of a cool like self-replicating cycle. It's called rep rap. At least like the philosophy is. Yeah,
That's cool.
pretty cool. Yeah, this print is supposed to take like half an hour, so yeah, it's about 15% through. But yeah, does anyone have any more questions?
Which one are you making it?
What?
Which one are you making?
I'm making the Charmander right now. But yeah, 3D printing is pretty cool. I found that it's a pretty useful skill to have when I go into industry. I don't know if any of you are engineering majors, but I'm guessing some of you are. But the reason why this class is remote right now is because I'm on co-op, and where I'm working right now, I bring this printer to work and I make stuff. So, you know, there's 3D printed stuff that we take out on the factory floor, implement it on the line. Well, a lot of the times it's for like less critical stuff because like, you know, if you need something super strong, they're just gonna mill it out of metal. But you know, if you want like fast turnaround times for stuff, like this is really great.
Where do you go?
So I'm working for Newport Tubular Products right now. So I'm in Kentucky. I'll be there till December. So, you know, we specialize in making electrical conduit tubing. You know, any of it's in here. But if you ever like go into a warehouse and you see like the metal tubes that go into like the outlets and switch receptacles and stuff like that, that's what our division specializes in. So, you know, take a big roll of steel, turn it into pipes and galvanize them, then send them out to customers. I know there's one thing that was a specific 3D printer application. There was like a sensor that needed to be kind of protected. I think there was like an airline that ran around the sensor, but it couldn't be shielded. So, you know, metal can like prevent signal from some sensors from escaping. So they specifically had like they designed and printed like a plastic shroud around the sensor to, you know, direct, I think it was air around it, but also allow, you know, the sensor to read through like the 3D printed like material and read whatever it was supposed to. So there are applications out there. You just need to find them. And if you can find them, it's pretty sweet because you can bang it out in like a day and then you're like, it's out on the line. And if it ever breaks, you just print another. So yeah.
We'll refine the design.
Yeah. I do have that.
Yeah.
This thing's been abused, but I printed this wallet like, I don't know, almost over 4 years ago.
Is that like a rich wallet type thing?
No,
Not quite.
it's just a printed wallet. I have a nail through it, so it can flip this. I mean, I ground down the side, but
Mhm.
you know.
Because I got like a fake. This is the fake rich wallet.
Oh, nice.
Yeah.
Yeah, but
You just print it.
yeah. This is just 3D printed. I modified to put magnets in it, but I never did. I was lazy. I pass it around. Please don't steal my credit card. Oh, bitch, you just the picture is not my $3. But yeah, it's just 3D printed. I have like a couple pieces of felt on the side just so the card slides smoothly. But yeah, it's just printed nail.
We quite need to learn from you, so let's all take a picture of his wallet with his credit card.
Oh yeah.
You have to make the notch when you're designing it like in CAD. You have to like do it like after you print it, and you have to like do like the nail thing.
I think I just made a hole and then I just pushed the nail through it and ground the other side of the nail. I was in high school when I made it, so I was just kind of being sus.
I mean, technically,
making stuff.
you just use a piece of filament.
Yeah, you
Design it for
could.
that, yeah, because it just rolls around it.
So is there any like, what's the good price for like a El Cheapo entry level beginners 3D printer is 3D lithography?
I would say like absolute minimum is like 200 to 300. At least I would recommend that to get something nice and reliable that you don't have to mess with. Like, you can spend less if you are into that and you want.
$40 Temu.
Yeah,
No,
like,
commercial.
I mean, like, a lot of you might be familiar with like the Ender 3, which is like,
That's what I have.
Yeah.
it's not a bad printer, but if you want it to like, print faster or print more reliably, you're gonna have to modify it a little bit, if you don't want to be, but, I had an Ender for a good while, but now it's in pieces because I'm gonna upgrade it. Yeah. But if you want like a printer that just goes right out of the box, like Prusa and Bamboo are like the two like big companies that kind of fight each other. Personally, I lean more towards the Prusa side just because it like kind of goes with the rep philosophy. So they've been a big player for a long time, and the printers I had before this were Prusas, and I still have them. So whenever this thing like breaks something, I fire up the Prusa. It's slow. It's Mark III, but it'll make a print and it'll work. And then this thing will be running again. So they're great. A lot of my friends have Bamboos and they're awesome. But it's not sticking with that like rep philosophy. So it's more closed source. You can't really modify things as much. But lots of people run print farms with Bamboos without much problem. So just kind of depends what you're after. This is, a boron trident. Oh, I shouldn't put my finger in it. This is a boron trident, so you can't can't really like buy one, but you can get one as like a kit. So like different like people like manufacture kits, and I bought a kit and I built this. But you can't like buy a working one unless you buy it from like some secondhand person. So, in my opinion, if you're gonna like build a printer, just like go all out, see how crazy you can go with your budget. Just because like Bamboos are so fast, like it's getting like increasingly hard to justify me spending a lot of money on this. Unless I'm going for broke and like, building it for a purpose that is beyond the capabilities of Bamboo. So like that's just my opinion. Some people will get mad at me for that because they love their borons, but it's just kind of true. Like the kit costs like 900 and you can get a Bamboo for like 6, right? So
A1.
yeah, well, I mean, a P1 is like 550, 600, which will get you in a similar ballpark to this. It's enclosed. It's not like the chamber temperatures won't be as hot, so you might be more limited. For things like ABS and stuff, if you have higher chamber temperatures, you'll get better layer adhesion and make the part stronger. So even though two printers may be enclosed, like this theoretically can make a stronger ABS part, right? So that's just kind of getting in the nitty gritty. But yeah, it took a good amount of time to get this where it is. So, you know, it just kind of depends what you.
And I have a few questions. Okay.
Yes.
For the final project, what is it like the largest dimension?
Oh, yeah. Okay. So this build volume is 300 by 300 by 250 millimeters. Please do not send me a cube that is 300 by 300 by 250. I will not print it, or I will just scale it down. I get a lot of finals that are larger than the print volume, so I just scale it down. But you know, please keep it reasonable. Like something about the size of this Charmander would be preferred. But you see like some people print bigger stuff like the bell towers. There was a Saturn V rocket that was pretty cool. But you know, that thing's really skinny and tall, which I don't mind printing, but you know, make sure to watch out for thin features. I guess while we're waiting for this to print, it's a time to kind of go over some stuff. This one, yeah. So, okay, I will say like this model is super cool. Like, you know, this student definitely spent like a lot of time making this, and I appreciate the effort. Oh, yes. If you can see, this is a TIE fighter. Someone made it in last session, and it's really cool. Obviously, like because of this model's geometry, you're kind of limited in like the way to manufacture it. Because this is one piece, like I had to make supports that go up and support it. Obviously, like you want to avoid that, but you know, because it's a TIE fighter, you can't really make this down here. So, you know, you kind of have to have supports. Something like this very not yellow banana. You can see like this bottom face is flat, which isn't a problem, but again, you do need supports for this. If you wanted to model this to not need supports, you can maybe have these like legs kind of slowly combine to the bottom so that you don't need supports, or make like the area that is flat, not very large, just so you don't have to have like really long bridges. So yeah,
Instead of doing it flat, could you kind of do like you were showing last class where you do like a teardrop shape thing?
exactly, yeah. So if you like chamfer this, kind of going up at like a 45-degree angle, that would like solve your support problem. Obviously, depending on your model and what your needs are, that may not be the case. But I encourage you to think about that when you're designing, just because, you know, it'll save either me or you time. You won't have to take out the material. It's a little bit less waste. And then when you're designing like parts for like a line, you know, you're going to print like 1,000 of them. You don't want to have to remove supports, right? If you can design it out, then like do your best to do so. But obviously, you know, for something like this, like there's very specific geometric requirements for a TIE fighter. Like you're going to need supports, but yeah. Obviously here, like underneath all of this, this is a pretty bell tower. So you can see here, like where things kind of start to get like more, please don't do this kind of thing. I mean, like the bell tower is great. And I like seeing the models because they're really intricate and like people obviously spend a lot of time on them. But you know, they do take a considerable amount of supports to print. And like at this point, like I don't want to let the person who comes in. But yeah. Just keep that in mind. Again, I will print it. I'll do my best to print it, but just there was a basketball hoop. Someone printed a basketball hoop, and yeah. Again, I appreciate the effort, but like they made like the net, like they modeled the net, right? And again, that's a lot of effort. I appreciate it, but it's like probably going to be kind of weak, and it might break. So tell them sorry, but it might break. Yeah, I mean, you can super glue stuff, but you know, trying to make it so you don't have to. Um, in terms of like how thin something should be, I usually don't go anywhere like below 3 millimeters on like an important part, right? If I want something to be relatively strong, sometimes I bump it up to like 5. So like for like the net, like uh, you know, there's like that little extrusion that goes to the ring. If I remember correctly, that was pretty thin, right? So like if you were to remove the supports, like the net might break off. But if like that was a little bit thicker, maybe like 3 millimeters, it has, you know, a better chance of surviving.
I remember him showing me it. I don't know the dimensions.
Yeah. It also could have been like the part imported really large and I scaled it down. Because again, if I see something that's just like I'll import something and then it'll like be like that big. And I'm like, I can't print that. And if like, you know, if they modeled it with like the right tolerances and like sizing in mind at that scale, that's probably good. But then when I scale it down, then you know, something that's 3 millimeters could become like 1.5. I scale it like 50%. Yeah. I feel bad because like sometimes I like roast my past students for it, but I don't mean it to like shame them. I just hope that I hope they learn. But yeah. Also, please keep things like school appropriate. I don't want to put like inappropriate objects. That'd be kind of weird. I probably have told people the story of me telling people not to have really large bridges, and then someone sent me a Golden Gate Bridge. Please don't do that. That thing took like I didn't print it, but someone else did, and I think it took them like 3 or 4 tries because like they modeled each like span of the the suspension bridge, and you know it's really thin, so like it was like about the width of the nozzle. So it was really hard to post process. And I think it broke as we handed it to them. I felt really bad.
Sure, have some that in.
So yeah, keep in mind like the nozzle is 0.4 millimeters wide. So anything smaller than that will probably like get ignored by the slicer. The layer height I print at is about 0.2 millimeters. So again, anything smaller than that would probably get hidden.
Can you say you print bigger than you can scale it down? Would that be smarter to do?
I mean, if you can just model it straight, then I wouldn't have to scale it at all. And yeah, it's I mean, technically, if you made it smaller and I made it bigger, then that would be better because if something was 3 millimeters when it was small and I scaled it up, then it gets bigger. But yeah, you have like units on Fusion, so you should be able to realize that.
Yeah, I'm on a Zoom.
Yeah. And also, if you have any questions about your final, like, you can send it to me and be like, hey, like, is there anything like that looks unmanufacturable? And I can like be like, hey, like this looks too thin. Like I would change this, or like this looks good. Yeah. I'm stressing like design for manufacturability. But I know that some people want to design stuff that's cool and like, you know, it might not be as hard to, or it might be more difficult to manufacture. And that's when I kind of get more lenient because like, sure, this wasn't really designed for manufacturing, but like, this is really cool. Like I give you 4 points for this. So, no, not like a super grader. Unless you like, just don't do it. So please just turn it. I'll say like, yeah. You know, 5, 5, like 5 teachers, it's not like 5 extrudes. You can do that pretty easily.
That you work to 5 extrudes.
But
It's like 5 extrudes.
technically, yeah, like you could like extrude 5 blocks on each other and technically get like 100%. I might be kind of sad, but like, yeah, you could do so much more.
It's like if I want like extrude like a circle upward, like and then like have an angle, How would I do that?
I mean, you could use like a sweep. So you could like draw a circle and then like on another sketch, you could draw like a line going off the center of the circle.
Okay.
You can do that.
Oh, I know.
There's like a bunch of different ways. So
Yeah, design. Oh, goodness. Oh, no, go ahead, please.
Oh, so I'm just asking about homework, like the rendering. Do we just screenshot like this page itself?
oh yeah, so you want to take like click on this and then download it.
Like
There should be like a download.
okay, perfect. So
Yeah.
that's the image. I want.
Yeah.
I forgot about that. I put a chair in the desert.
Hmm?
That's like a random chair in a desert.
Oh yeah.
That's my
That's fine.
PNG.
It doesn't matter as long as it goes on the Google form.
For things like, I was looking at this part of the frame. How would you go about designing this kind of pivot over here?
Oh, that's a good question. I'm pretty sure what you could do is you could do like you could like offset it off the surface and then do like an extrude, or you could like extrude down by a certain number to a surface.
You can just have a curve and then just extrude as a
Nice.
subtractive material. Yeah.
Cool.
Uh,
Kind of like how we did with a 2D where we like did the bridge at the beginning and we just put
Yeah.
like the circle and then take that off.
Yeah.
Pretty much.
Let's see.
How do we access the rendering? You just go here and stuff.
Sí, pero esto es lo que lo tengo. Como lo hacen en- esto es- That's so cool. Thank you.
Um,
Which is a curve.
for stuff like text and like
Thanks, you know.
um, textures, like the printer is generally pretty good at like replicating some small features that are extruded outwards and inwards. So for stuff like embossed text, like don't go like 5 millimeters in because like if you think of like, you know, an A, like the center of an A is like a little triangle. And if you have like the letters embossed by 5 millimeters, then like it'll have to like bridge or like do an overhang to make that center of the A. So I'd say like if you want to make the text go in and out, I do like 0.5 like in each direction, and the printer can usually do a pretty good job at like replicating it and it still looks nice.
What was the reason again for not being able to go bigger?
Like if you like, let's say like this is my hand and it's like turning like this. If I like cut into my hand by a couple millimeters, like let's say like again I was doing an A, the center of an A is like a triangle that's extruded out of like the back face, right? And if you remember like that cylinder example from last week where like you saw like the supports underneath that cylinder that came out, like you would need that for the A because it's just sticking out,
I see.
right?
Yeah.
But if it's only like 0.5
It's not
millimeters,
so much.
it's enough that the printer can just like do it and it's like it doesn't really,
Oh, cool.
you can't really tell.
It won't deform just because.
Yeah, like if you look at the grip,
Uh-huh.
like that hex stuff is technically like an overhang, right?
Oh, okay.
But like I didn't print supports because it's only outwards like by enough to the point where you can't really tell. Yeah. Yeah, pretty much that.
So yeah, press something.
I probably should have chosen faster model.
Probably, yeah.
Oh, no, it's gonna be worth it.
Yeah, it'll be.
It'll be definitely worth it.
The print quality is crazy good.
Brawl for the charm.
Okay, I'm gonna ask it. Can I keep it?
I think it.
Well, I don't know. We'll see if there are any objections. I'll print a speed benchy too, so if anybody wants a benchy, they can take that.
I'll take the
I'll take 20.
What?
I'll take 20. You have more than 20.
I have like, yeah,
You
I have
more
like
than- you
I have a
have-
container and it's just full of benches.
So how much material you
Pero no solo
Depends on the material, but for that, yeah.
Like,
And some has a support.
This started as a full roll. I printed all this green stuff. Like, I printed all the green stuff for the finals with this and I'm still not done. So this is I probably burned through about like 400 grams. But this full spool is probably like $25.
Oh,
So,
Yeah.
you know,
I thought it would be way more.
Do you have a
expensive.
budget for this class? Like at least Purdue, whatever mechanical engineering program sponsor you some?
um, So, Alejandro, like the person who kind of oversees like the milestones courses, just kind of gives me some films and I print it. So I don't really have a budget. I'm just like, can I get some?
What about gas money? Last time for the gas
I was,
honestly, like it's
I would-
actually honestly.
maybe I should.
Yeah, maybe you should.
That's like,
Travel expenses, work
Yeah.
expense, yeah.
I
Business
drove,
expense, yeah.
I mean, here to Kentucky is like 200 miles. So I drove like 800 miles a semester for this class.
Yeah.
Push this guy like yours.
Yeah,
No,
I'm just sad. I'm just sad that you guys didn't fill out the attendance forms because then I'd have an excuse to bring food. But then I learned that last time that food's not allowed in this room. So
Ah,
so we
wow.
have to like eat outside or something.
that's fine.
What does it? I'm gonna pay for you. You're worth it.
Is that Big Ben?
Got another question. And this says, is the rendering gallery function the final expected product?
Yes, sir.
Use the closet seat set.
Careful, we're gonna- Across.
As in, like, I didn't do it today, my father because like. I can start it. It should be.
What is it?
That's not.
That's the very simple today.
I think somebody else asked, if they could repeat the process after. So,
Okay, we're
Let's see, we use one that's built above you.
Yes, so you don't have to, just don't use like just the like.
Yeah, I'll use like field or something.
Yeah.
It's fine.
But there is extra
Good
credit. That's
cool.
Yeah, that's the unload sequence, because it'll cut and then.
Push it off.
Yeah.
Does it automatically switch between filaments if you want to change colors, or do you have to do it manually every time?
Yeah, that's what this is for.
Oh, that's so cool.
Yeah,
So
so it's automatic.
when I'm done, it'll do 12 colors at the same time. It's just really excessive,
So
but
cool.
it's doable. Yeah. I know some people who do 21, which is kind
It's
I
for
like-
bragging rights.
of, like, I did 5 for him. I don't
Yeah.
think I'm ever gonna do 5.
Or you
Yeah.
can snap it
It's
off.
just sample, like I'll tell you, but you printed 5
Or
colors.
it has a whole back.
Let's shift the colors every,
Yeah.
it's different color.
I will print a
every-
speed bench,
So-
so you two can.
That's how I swap
you
them.
can for you over against the challenge.
Like,
oh, that's why there's
How
a,
about a rock, paper, scissors competition?
I mean, I did
Feel
that
down?
first, to be honest.
Well, he also raised his hand when you asked him, so if you want,
It's fine.
you can rock, paper, scissors.
I'm good. So what's the deal with that bar in the front when there's something like?
Oh, yeah,
Yeah, what's
so
what's
this is the approach line, so, whenever you print, like, there's pressure in the nozzle. So this purge line will, pressurize the nozzle before it starts.
Oh,
And I made it extra long because when I print other colors, it'll have to purge out the old color.
Mm.
So like, if I was going like, if I was printing something green before and I'm printing red, it'll like purge out the green. Yeah. I'll just here, you guys can rock, paper, scissors. This bed is like made of the spring steel and it's coated in this textured PVI. So it's nice because you can like slice it and like the prints will fall off. That print was big enough that I can kind of rip it off.
So how do you need to change this, plate?
You should never have to change the plate. Unless it gets like really, really worn down. I was kind of dumb when I was like first building it and I like tried to run it without tuning everything. And I would like crash into the build plate and you can see like
oh,
scoring marks. or-
Also depends what type of texture you want on the first layer. So that's the difference, the bottom is a PEI, the top is glass.
Oh, yeah, top looks really.
Yeah. It depends on the
Oh.
finish. It's like, do you want texture or do you want to show the line? Yeah,
Yeah, it's
it
kind
depends,
of a
yeah.
preference. Um, some different materials
Super good.
like different build surfaces. Um, yeah, I think it's for a keyboard, so that's pretty Benji.
Thank you.
No problem. Maybe I won't for too much.
Do you think you'll do it under 10 minutes?
Well,
No.
I haven't tuned my speed bench up yet. So that's about 20 minutes.
Yeah, you got out that time though. Didn't you see anything left example? Or someone has an example or something?
I think they left. No one's here now.
What's the longest single item you ever printed? Like 16 hours, something like that.
I printed like 23 hours on my old printer. I printed an MMU thing for him and it took a week.
Yeah.
And you can now pause it or yeah. So it's just,
So depending
I forgot.
what'd you forget?
No, I was supposed to make him bookends.
Oh,
It was my final product when I took this course,
Like
over a year ago at this point.
do you still have the files?
What?
Do you still have the files?
I have
I don't know. I think so.
I definitely I have them in the submission somewhere.
I mean, if anything, I can
need to
print it for you.
No, I can print it.
The next time he comes back.
I'll be back. I'll be back this weekend and here.
I'm not here this weekend.
Oh,
I'm going to Evansville this weekend.
Okay. Are you here for Thanksgiving? I guess no.
No.
Wait, oh wait, I could stop by Indy on my way up if you want.
Good.
oh, by the way, I'm thinking going to design something like a better mount for this. I feel like there are going to be some resources online, but like I'm going to try
Yeah.
to do one. Like, of course, this is not my final project. Too
Yeah.
complicated.
No, that's not too complicated.
It's all right.
Let's try like something to pull down.
Yeah.
This is
I mean,
kind of-
I would encourage it. But just know that like a print might snap on the layer lines.
oh,
So if you printed it like flat like this,
Yeah.
right? And like, it was flat here. If you like hit a bump, it would snap on the layer line.
yeah,
So
I
the
can-
print orientation also really matters.
yeah,
Cause like,
yeah, this will be my final project. It's going to
cause
be,
like,
Yeah.
the tail would snap like here.
yeah, but I'll pick you up once I figure out the design like someday.
Yeah, sure.
Yeah. By 2027.
Ah, it shouldn't take you too long. You got it.
Stop
Hit
sticking my
it,
finger.
your finger in the fan.
Ah. It's the fan of
It's a cooling fan.
electronics.
Yeah.
Oh wait, I can show you.
Design something like a better.
I saw somebody
Fan.
asking how to do
If it
this.
covers more,
Can you
it's,
get-
it's also.
Okay.
You wanna-
Yeah.
wanna go over it now or just like.
Yeah, I'll
make
just
a video for it, just because it kind of messed up the first time.
Yeah.
Don't you- Okay, I'll do the scene thing again. I need to share my screen.
Yeah.
Okay, sorry to the people who are just sitting there and
And so.
listening to me ramble.
Why?
Okay, so no.
No, you gotta buy those. You gotta
You
buy
have to
those.
buy these?
Yes, yes.
Yeah.
Because the truth ends.
I could it'd probably like explode like if I printed it.
You should try to print it too.
Okay, now I want to. Okay, so if you missed it's for a keyboard, I think. So you're supposed to put it on your keyboard. So I'm not sure how how you do that with the tail.
No, I can't. So like another.
Huh.
I have no idea.
I don't know.
Anyways,
Maybe it's
if
just
you're
supposed to
wondering
be a
about
lot
the
simpler.
scene settings,
Yeah,
um,
it was like how to apply the scene, it's basically the whole thing.
okay,
How to apply
yeah.
it and then render it.
So you just go to scene settings up here, next to appearances. You want to make sure the background is set to environment because if you don't change this, then it'll stay as a solid color. So once you change it to environment, you can go down to the next tab and then you can change the environment. For some reason, it's not giving me the option to do like the outside environments. I'm not sure if I just need to restart my program or something, but typically there's a couple of options that are not just light, like Plaza, and like a couple other ones. So please use those because if you just use the light one, then I'll assume that you didn't know how to use environments. So please don't use the light ones.
Yes.
I know like for some of your finals you might prefer that, but
Support.
please just choose something that's not that so I know you know how to use it.
I feel like
So you just double click on it and then it'll apply it while in rendering mode.
I feel like it depends.
Um,
It looks like there was
to kind of preview your render and do like a mini render locally, you click the in canvas render button, like this play button in the corner. It'll get fuzzy and then progressively better. But it'll give you like a preview of what your rendering is gonna look like.
Yeah, can you run that real quick?
You can rotate it and you'll see it gets
It's all
blurry.
about the many settings.
You can see like the light source. But yeah, it'll render. When you want to finalize your render, you just click the teapot.
It was like a new down from the front.
That's super cool.
It'll load.
Which is after like the next
The next big, yeah.
Here, sometimes depends on the
I just leave these just as it is. If you want to change it, you can. But the most important one is setting it to cloud render and then final. And then if you have your education license all set up, you should be able to just press render, and it could go. So let's see, we have unlimited final renders because of our education license. You click it, it'll send it to Autodesk and render it, and it'll pop up down here. I believe mine has maybe finished rendering. Not sure. But once it finishes rendering, you should be able to click on it. It'll allow you to preview it, and then you should be able to download it. Okay, well, I have an error, but you can see here, there's this download button. I think it's just because I need to update my Fusion, but once it renders, it'll give you a preview here, and you can download it with this button, and then you can submit that. But yeah, I hope that is helpful.
The settings I have in this, anything above 60 degrees, it works. But if I set it to like 30 degrees, I said the tail will have support. And also the cat's head will also have support.
Oh,
Yeah, because that's also 45. That's above 30 degrees.
those are the three supports.
Yeah, those are the tricks. That's yeah. But yeah, most of the time you want minimal support as possible because ultimately supports are meant to be thrown away.
Yeah.
Yeah. There's sacrificial material. Yeah.
Is it possible to recycle supports into like your strands so you can reuse them?
It depends. Some people have actually managed to melt it down so that you can actually turn it into spools, but that's a whole different different system. Yeah, it's like
You need like a shredder to shred the material. Yeah, and then you need to like dry it, right? Just because you don't want like bubbly filament. And then you need to have like the extruding system, but then it has to be accurate enough that like the diameter is very consistent, right? So there's a bunch of different ways people have done it. People have done stuff like recycling plastic bottles and turning it into filament, which is pretty cool.
Really cool, yeah.
But as of now, like something that's like really convenient is not really there yet, in my opinion. I really want that to happen because I've been like saving like my scraps like over like semesters.
Oh, really?
Have like a big bin of just like
for one day, so you can like push them all in.
yeah, like if there was like a service that would do that, I would totally like ship them a box of filament and have them like send it back to me. But I know it exists in Europe, but I don't think they do it here yet, which is kind of sad.
unless you live like next to it.
Game
Astroneer? I have not.
I feel like you'd enjoy that game. Just enjoy. I feel like the automation process is amazing.
Really?
Yeah.
That's
They could just DIY.
wait, like what is it about?
Astroneer.
Astroneer?
Yeah, it's,
I mean, it's something possible in the nozzle.
it was pretty fun when I played it.
So then,
You shoot it.
yeah, shoot it straight down. So electrical is like the string, and then you have to make sure the diameter.
But you need to pick up the three. Yeah, which one's yours?
Okay.
Oh, it's like
I will
you
take a look
DIY.
at
I
this.
thought it was so complex you would really need to like buy it.
I mean, yeah, some people they just make the whole machine, but that thing is $3,000.
Yeah.
That's
You do
First
it
time the
all
cost of
day.
this, yeah, exactly. It's like you have to have so much material that goes through it, but at the same time, not enough where you have to remelt everything together. So it's like it's like the middle. Yeah, and I think there's apparently, Andrew,
Yeah.
apparently there's like desktop filament extruders, but that is up to almost $700 right there.
Like an okay setup would
Yeah,
probably
it's
run
an-
you anywhere from
it's an
like 2
all-in-one.
to 3 grand.
Yeah.
With that money, it's just better to buy one of these.
Yeah,
ones.
it's at the time,
Well,
just
it's better just buy.
yeah, sometimes the filament is so cheap that sometimes you have to value your own.
That's true.
Yeah,
Like if there was like one for like $500, that was like okay.
yeah, that would.
That's probably worth it. But
But above that, so it's just like,
yeah, like
Yeah.
that Charmander probably was about like 10 cents
really,
max.
wow.
In material, you also have to. Obviously, if you in 3D modeling, you have to like consider how much you spent modeling, the idea, the electricity bill, and all that stuff, But
Yeah.
in
I
terms
mean,
of material,
I'm stealing Purdue electricity, so it's free.
it's totally not like we paid for it.
I mean, here, the slicer will calculate the weight. Like, remember if from the slicing assignment, it'll tell you the weight. So you can like go off like the price per kilogram and then get
And I go from there.
the
That's
cost.
really cool.
Yeah.
This runs at about 2 meters of foot. There's no way that's 2 meters. Right? Oh wait, no, it's 2 meters.
Let's
of
see.
Point.
Yeah, it's like
Yeah.
it was like 20 grams and the spool was like $27
Yeah.
for 1,000
divided.
grams.
Yeah.
So, pretty cheap.
That's so cool.
I printed this for I brought my printer to lab today and just printed it in front of my professor. And obviously it's not as quick as his, but everyone I'm in AET, it's like we work and all that stuff. So that was pretty like
Oh, yeah.
amazing. It's not as quick as his, but there's $100 for it.
Feel really cool.
Yeah. At the end it was just that. Just gold.
That's material for printers that are open, that don't have like the enclosement.
Definitely the easiest would be PLA.
PLA?
In my opinion,
Yeah.
it's PLA. Yeah.
PLA is basically the most common.
It's like the default.
Yeah.
It's like you can get spools as cheap as $10. I don't suggest you going that way because there are some that's like really good quality for $15.
Yeah.
The orange I use for that,
Uh-huh.
it's the designer of that blaster, he prints literally all of his blasters that he sells himself in that PLA.
Wow.
Yeah, so he trusts it enough where $15 or $16 per week, he's really comes on right now. And you can get in handful colors. But yeah, I feel like it's called PLA Max, but any PLA should work similarly. Yeah. Where you don't need a heated bed, but heated bed will help with adhesion, I think.
For the first layer though, I don't think it'd make a difference for any of the others.
Well, I mean, it does for like, like warping and stuff like
Oh,
that. Which is why like when I print ABS, I print with like a bed of 105.
Oh, wow, okay.
Just because it'll prevent warpage.
That's
And-
super cool.
But let's just say if you print just the printer parts from an and it's gonna use like half a spoons. So it's like technically speaking, if it doesn't break, it's like $8 of filament.
Yeah.
So
Andrew, where you gonna be this summer?
I don't know yet.
You don't know yet?
Yeah.
Okay.
I'm kind of curious on that myself. I don't know if I'm gonna be here or.
If you end up staying around here, you should let me know. That way I can visit your place and come mess with you.
That would be cool.
Thank you guys.
Yeah.
Appreciate it.
And then hopefully I don't place.
It's okay. I can reprint stuff.
there's about overtime.
Oh, no.
My monitor is here tonight. It just got delivered.
Andrew,
Oh, no.
can you give me a pizza party for my poor attendance?
Yes.
Yes.
I don't even think I would have made the.
I love how this is just. Do you print
3 out
this?
of 5.
Do you print this? No. This is just normal.
That's kind of cool.
Yeah, I know. I saw it here. I was like, oh, that's
Yes, I am about to close the Zoom, so thank you for coming. I'm sorry you couldn't be here today.
T8 keyboard.
Okay. I have to go try to find some dinner before my meeting at